So the graphic you see here, this is basically a time series NDVI of Africa. You see here some interesting pattern. You see greening moving south to north throughout the year. What that means is simply throughout the year, there is a weather that creates more precipitation from north to south, and that leads to growth of vegetation, and that's what we see through NDVI. What it means is that there are sensors like AVHRR that has a 4-meter resolution, 4 kilometer resolution, and 1 kilometer resolution, and also MODIS data that we can be used to create these monthly, annual NDVI, and once you stack them, you see such kind of pattern where you see greening, and greening that follows weather pattern. When there is water, there's a greening, and as it gets drier, that productivity decreases, and that's what you see in this graphic. So until means this Google Earth Engine, to create that kind of data could take months and months to download all the satellite images, mosaic them, create NDVI, and then create such GIF file or video clip. But with having Google Earth Engine, these are like these kind of creation can be reduced to 10 minutes, less than that. Sometimes it takes more time to save that outcome to your local drive. So many of you have used Google Earth Engine, and if those who haven't, it's very intuitive online platform. It is freely available, and Google Earth Engine has access to all the NASA, USGS satellite images, and also from European space agencies, and many projects that has been processed using those data funded by NASA and USGS, and they're also available through Google Earth Engine. In Google Earth Engine, there are 4 panels. The lower, left upper corner, that is where you see your script. That is where you upload your asset. Asset means shapefile, location shapefile, polygon, point, line. And also, that's where you can also look for any kind of function you are interested in to apply your code. The middle panel, that is basically where you write your script. The right portion is basically console, where you have inspector, console, and task. What it means is that whatever analysis, whatever script you do, and once you run, you can inspect that through inspector. And once that is processed and ready to download, you will see that part in task. And the lower part of this Google Earth Engine portion is that map. That is where you can visualize all the layers that you have processed using map, a satellite. Map in the map portion is basically a simple graphical layout where you see all land objects. But in satellite, you see real satellite imagery. On the same window, upper left corner, that's a geometry tool that you can use to create any kind of geometry from point, line, polygon, rectangle, or any type of. And also there's a zoom option that you can zoom in and zoom out your window. So these 4 panels basically are the essence of this Google Earth Engine, where one place you create your file, in the middle you script, and you run the script. In a task, through task, you save your outcome. And in order to visualize, you use geometry tools also. Through this scripting, you can also create graphics of whatever any analysis you do, that I will show in the next panel. the place you see search places and data set, that search portion, that is where that is where we plug in search any kind of data available in Google Earth Engine to plug into our script. So the earlier in the previous presentation, I showed you this particular slide, time series NDVI estimation. And this example is based on the script that I will share with you in a few seconds. Just few things I want to emphasize is the pattern of different vegetation types, including water bodies, how they change within a year and between years, and how they differ from each other. To take you to the script, so I just clicked to run. So as I said, there are 4 windows, so 4 panels. The one you see here on the left side, that is all the scripts I have created over in last 5-6 years. I have all the scripts here. The one I'm sharing is just I created for this workshop. And here is that you define study area, you plug in your land cover plots, means location data through asset. You can create visualizing elements. What it means is that there are packages available that you can use to visualize your outcome. Then type of remotely sensed imagery. In this, I use Sentinel data. You can use any data, the one you wish to analyze. In this, the time period I use, that is January 2019 to December 31st, 2021. Okay, and cloud percentage means, so here's the thing, whenever there is satellite image, they often they have some cloud coverage, and based on this percentage you can filter them out. So the one I used, that was 5% as a cutoff. Then we can add the function of and calculate NDVI, and then extract NDVI value for each polygon. Whenever we do estimate NDVI, it's always good to use polygons. Why? Because all the pixels within polygon help to capture the variability of NDVI within that polygon. Often farmland, they are not uniform. Some portion has higher moisture, so more NDVI. Some has a lower, some portion of the farm could have some kind of pest and pathogen infestation. So having polygon helps to capture all the variability within that polygon area. And then there are a few more functions that can be used to, once you have NDVI estimated, you can create the chart. Okay, so this is the scripting part. And here's the thing. Inspector, there's no any issue, so you don't see any comment here, but in console you can see all the functions I used, outcome of all the functions I implemented. Means you see 223 elements, that means there are 223 images, and then you see a list of NDVI values, like a unique ID I have, that is forest 001, forest 002, and then an NDVI, the date and then value. And there are 3 graphics you see. So 3 graphics, and one NDVI value is based on an average of all the polygons. And the middle one here, the one I shared with you earlier, that is for each individual farm. And here only I just picked the 5 different polygons: forest, water, farms, and grass. Okay, so I'll show you NDVI of those 2 different watershed or different water bodies. And this is where you see the layer. So all the layer I created, layer 4, land cover plot types, Virginia district, means if I click, you can see Virginia district will be uploaded. And the black polygons you see, these are the polygons that I used to extract NDVI value. So this is one of the, this red color polygon is one of the water body. And if you see the satellite portion, you see how greenish it looks like. Greenish it looks. And this is a one, because this is a one-time high resolution means image from Google Earth. So it's hard to see the time series, but it shows that how much greenish hue is in that water body. And that is why you see some values, some NDVI values above 0. And the same, and the other water bodies that had little different this is the second water body, which is a little bit has lower amount of NDVI, lower amount of algal bloom, and that's why you see difference between these two NDVI values from these two water bodies. So, and in a task, finally, this is what at the end you get, and once you click run, it will connect you to your personal Google Drive, and it will be saved in that file in the format you wish to share. In my case here, I have used that is CBS format. So overall, in a simple, using Google Earth Engine, you can create land cover maps for any time step, any part of the world. Same way NDVIs. And earlier there was a question about dry matter. You can also estimate dry matters, biomass, evapotranspiration, many parameters of vegetation types or landscape types. You can calculate using Google Earth Engine. It's just a matter of identifying the right functions, and functions are available in docs. And once you implement and you have in a proper order, you will have a product of your desire. With this, I will end the presentation. And if you have a question, I will be happy to answer that.